Video will help you with looking at experimental probabilities when you're dealing with coins or other data. So looking at question 1, Tom and Nancy are trying to decide who will clean the dishes. They decide to roll a cube. If the rolled number, or the number rolled is prime, Tom will clean the dishes. If the number rolled is composite, Nancy will do the dishes. Is this a fair way to decide who will do the dishes? Explain. So, first I would think about what are the prime numbers that are on a number cube or on a die. So prime numbers have exactly 2 factors, so that would be the number 2, 3, and 5. Remember, the number 1 is not prime because it has only one factor, 1. So now, looking at composite numbers on a die, those, remember, are numbers that have more than 2 factors. So on a die, the composite numbers would be 4 and 6. So looking at these results, we can see that you're more likely to have a prime number than a composite number. So because of that, it is not a fair way to decide who does the dishes, because in the long run, we would expect Tom to do the dishes more often than Nancy. So this is not fair. In the long run, we would expect to get a prime number more often. So Tom would do the dishes, clean the dishes more often. Okay, looking at our next problem, you write the factors of 12 on a piece of paper and place them in a bag. You then select a piece of paper from the bag. What is the experimental probability of selecting a prime number? Well, first we have to figure out what are the factors of 12. So if we list them out, remember factors mean they divide evenly into 12 with no remainder. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Looking at those factors, now we have to pick out which of those are the prime factors of 12. So looking at that list, I'm picking out which of those numbers are prime, and remember that means they have exactly 2 factors. So 1 is not prime, 2 is, 3 is, 4 is not, 6 is not, and 12 is not. So those are my only prime factors, 2 and 3. So the probability of getting a prime number was, there are 2 prime numbers out of 1, 2, 3, 4, 5, 6 numbers in the bag. That reduces down to 1/3. As a decimal, 0.3 repeating. As a percent, 33.3 repeating percent. For part B, what is the experimental probability of selecting an odd number? So looking at those factors, figuring out which are the odd numbers, if we list them, would be 1 and 3. So the probability of getting an odd number would be 2 out of the 6 total, which reduces down to 1/3, 0.3 repeating, 33.3 repeating percent. I hope this video helps. Let me know if you have any questions. Thanks.